My warm greetings to all. I am Dr. A. Kalaivani, working as an assistant professor in the Department of Physics in KPR Institute of Engineering and Technology. So, in this presentation, we are going to discuss about the fundamentals of optical fibers, especially about the Matlab coding for acceptance angle and numerical aperture. So, this slide shows about the introduction of optical fibers. Optical fiber is a flexible, transparent fiber made by drawing glass or plastic to a diameter slightly thicker than that of a human hair. These optical fibers are used to transmit the information from one place to another by using light signal, that is fiber optic communication. So here the information carried by the light wave should need a guiding medium through which it can be transmitted safely. The guiding media is called as optical fibers. So optical fibers acts as guiding media here, and light signal acts as carrier wave which carries the information. So this slide shows the structure of fiber optic cable. This fiber optic cable consists of 5 main components, that is core, cladding, coating, strength member, outer jacket. So among all the 5 layers, core and cladding are made by either glass or plastic. So core is present at the center of the fiber and it is surrounded by cladding layer. So even though both are made by same materials, the difference lies in their refractive indices. So the refractive index of core is always higher than the refractive index of cladding. The remaining all the 3 layers acts as protective layers for core and cladding. Next slide is the principle behind fiber optic communication, that is total internal reflection. So in this figure, the light ray which strikes the core cladding interface will be reflected back inside the same medium, that is core medium. This process called as total internal reflection, that is the light will not enter into the cladding medium, it will be reflected back inside the core medium itself, that is total internal reflection. So this is the basic principle behind the fiber optic communication. So this about the acceptance angle and numerical aperture. So in this figure we can see that the light ray entered inside the core will be reflected back inside the same medium, that is it will undergo total internal reflection. So the angle inside this cone is called acceptance angle, and the numerical aperture is the light gathering capacity of the fiber. So the formula used to determine these two, that is numerical aperture and acceptance angle. So for numerical aperture, the formula is the square root of n1 square minus n2 square, where n1 is the refractive index of core medium and n2 is the refractive index of cladding. And for acceptance angle, it is the sine inverse of numerical aperture. These are the two formulas used to find the numerical aperture and acceptance angle. So this is the Matlab coding in order to find the numerical aperture and acceptance angle of a fiber. So the first command is clear all, which clears all the already existing commands. So display fundamental of optical fibers, which gives the heading, and the first input is enter the refractive index of core, that is n1. So it gives the refractive index of core. And the second input is given as n2, that is enter the refractive index of cladding. So the formula for numerical aperture is n1 square minus n2 square whole power 1 by 2. Then display numerical aperture of fiber is equal to display NA, which is numerical aperture, which gives the value of NA. Theta is equal to A sin D NA. Theta is the acceptance angle, which is equal to A sin D NA. NA we already know that it is numerical aperture. A sin D is the sine inverse. So sine inverse of numerical aperture, that is acceptance angle. Then display acceptance angle of fiber in degree is equal to, and finally display theta. So if we run this program, so you will get the enter the value of index of core. So I am going to give the value as 1.5. So again it is asking the refractive index of cladding. So I am going to give the refractive index of cladding as 1.45. which is slightly lesser than Coase's refractive index. So if we enter both the values, finally it gives the numerical aperture of fiber as 0.3841 and the value of acceptance angle as 22.5852. So if we change the value of N1 and N2, we will get different values of numerical aperture as well as acceptance angle. So once if we know the value of numerical aperture and acceptance angle, we can able to minimize the signal losses which are produced in the optical fibers. So it can reduce the signal loss. That is the main aim of this numerical aperture and acceptance angle. Thank you all.